So what is your project name?
IoT based underground cable fault detection system.
Okay, it is the IoT base. We have used the IoT domains. Okay,
Yes.
and for that we have to use here the ESP32 microcontrollers because it is inside the Bluetooth as well as Wi-Fi. So that's why we are using here the ESP32. So this is the project which is consist of the three divisions. We can say this is the first division, second division and third division. Okay, the first division, it is a consist of the power supply. Because the microcontroller ESP32 is requires only the precisely plus 5 volt. If it is voltage more than the plus 5 volt, it will be get damaged. Okay, if the voltage is less than the 4.5 volts, it cannot be microcontroller cannot be work. It requires plus 5 volts of their operations. Okay, so for that we have to require the bridge rectifiers, then the filters. We have used the bridge rectifier here, the filters. We have used the C-type filters over here. Here we have used the electrolytic capacitor. This is called as a electrolytic capacitors. Okay. Okay. So we have used the electrolytic capacitors. So there are different kind of the filters we can use. We can say that the C-type filters, L-type filters, pi filter, etc. Okay, so here we have used the C-type filters because of the efficiency and filtering capacity of this filter is more than as compared to the another filters. Okay, what is the use of the filters? Filter, it is remove the unwanted components. Filter is remove or bypass the AC signals towards the grounds. It's only provide the DC signals. That's what is called the filter. And we requires only the DC supply for the microcontroller. So here, so we have used this one adapter, okay, because the it's provide the proper configurations of the power supply to the microcontrollers. So here we have used the 1 amperes and 1 amperes and the 12 volts. Okay, but here microcontroller requires the plus 5 volts, so that's between these adapters and this microcontrollers we have to use the one circuitry that is called as a we can say step down circuitry. Okay, so here we have used the 7805 7805 regulator IC. Okay, this regulator IC only provides the plus 5 volt for this microcontrollers. Okay, and relay requires the 12 volts. This one the relay, it's when we on this switch, then this LED will be blue. It is indicated power supply is available. Okay, so now when we press this button, this one LED will be on, and then power supply will be received toward this circuitry. Okay, so now this one circuit, it is a consist of the two major components. The first is a microcontroller itself, ESP32, and another is it is called as a OLED. It is the advanced OLED display in the market available because today you know that anywhere we requires or we can see there the compact and less component circuitry. Okay, so this is the OLED display. Okay, so it is a colorful message we can see over here. So okay, and we can say that the n numbers of characters we can display on this LED. Okay, so now next is this is the relay. Okay, this relay to connect or disconnect the 230 power supply. Okay, towards this load. Okay, this is our load, main load. We can see that the when there is fault is happened. Okay, according to that this one load will be disconnected from this circuitry. Okay, we can say 230 volts. Okay, if there is no fault, then lights will be glow continuously. So these are the fault detection. It is the live fault detection systems. Okay, these are the different wires we can see here. Okay, so the one wires it is in the zone of the we can say that Vasi zone. Another is this is for the Nehru zone, and this is for Junagar zone, and this is for the Kharghar zones. Okay, if they are the short, okay, to each others, and if the fault is happen that zone, so LED display will be show here the fault is detected in Vasi zone, otherwise Nehru or Kharghar zone. Okay, so now So if so anyone wire is by mistakenly connect to this ground, then there is it is indicated there is a fault. That fault will be shown on this OLED display. Same thing, this is the base on the IoT base. So all the fault we can see on the websites. So there is a one website. So there also we can see the which kind of the fault will be happens and where. THQ clients, ठीक है. इस वेबसाइट से हमने क्या किया है कि यूजर आईडी मिला है हमें, ठीक है. उसका वो सब लॉगिंग जो मिलता है वो हमें हमारे प्रोग्राम में ऐड करना पड़ता है, ठीक है. तो एक टॉपिक देना पड़ता है, अपडेट फॉल्ट डिटेक्शन. दिस इज द टॉपिक विच इज यूज इन योर इंटर प्रोग्राम्स, ठीक है. तो यहाँ पे वेटिंग फॉर द डेटा ऐसे आ रहा है, क्योंकि हमारा ये तो सब चालू नहीं है, तो यहाँ पे वेटिंग आएगा, ठीक है. थोड़ा सा जूम करो इसको, ठीक है. स्टॉप करो, ठीक है. सुनो, मैं पावर सप्लाई ऑन कर रहा हूँ.
Yes.
ओके. ये यहाँ तक पावर सप्लाई आ गया है, इसको मैं अभी ऑन कर देता हूँ, ठीक है. जैसे ऑन कर दिया, यहाँ पे डिस्प्ले पे क्या दिख रहा है आपको, ठीक है. अंडर क्या है, IoT बेस केबल फॉर डिटेक्शन
Using
IoT, ठीक है. यहाँ पे डिस्प्ले हो रहा है. ओके, ये समझ में आ गया आपको. तो यहाँ पे कोई भी फॉल्ट नहीं है, इसलिए ये चालू है हमारा. जैसे हम कोई भी बार एक दूसरे को लगा देंगे, ठीक है. तो यहाँ पे क्या बता रहा है वो, फॉल्ट टू डिटेक्टेड, नेहरू लाइन डिटेक्टेड. तो यहाँ पे हमारा जो लाइट है वो क्या हो गया, बंद हो गया, ठीक है. इधर दिखाओ, फॉल्ट 3 जूनगर लाइन डिटेक्टेड बता रहे.
Fault 2 इधर दिख रहा है, नेहरू और वहाँ पे fault 3
हाँ,
दिखा
तो
है.
इसको लगा देते हैं. थोड़ा सा रिलैक्स होगा. इसको कुछ 2 मिनट लगेंगे पूरा प्रोसेस पहले, इसके बाद वो फ्लो लेगा, ठीक है. कौन सा फॉल्ट है?
वाशी लाइन डिटेक्टेड.
एक एक लाइन लगता है. ये हो गया. नेहरू बोला अभी वहाँ पे जूनगर आया. तो यहाँ पे सर आपने उल्टा कर दिया. नेहरू की जगह पे जूनगर, वाशी की जगह पे खाल को वहाँ पे शो नहीं हो रहा है.
ये और वायर्स को भी ऊपर रखना पड़ेगा कैसे, ग्राउंड में कनेक्टेड है बाकी दोनों, तो वायर्स भी कनेक्टेड है ग्राउंड वगैरह में, इससे भी होगा ना.
हाँ, ये इसको इतना रिकॉर्डिंग कर लो, फॉल्ट डिटेक्शन. चलिए बंद करते हैं.